In this page, we discuss the shifting property of the Kronecker delta. What does delta n minus n naught means? Well, here we know that basically it is only 1 at time 0. What does delta n minus n naught means? Basically, at time, this is n naught. At n naught, we have 1. And everything else is 0. So for example, this is n naught equals to 3. This is delta n minus 3. What are we talking about? Why did this unit value move from this point to this point? Basically, when you substitute n equals to 3 here, 3 minus 3 of course is equal to 0, and then we are saying that the delta is only defined at when this coefficient time is 0, and hence that's why it appears like this delta is delayed to the right hand side by 3 samples in this example. Now, what does shifting property means? Shifting means to take out something, to extract something, and we can extract a single point at time index 0. What do we do? Well, this x of n is defined for all integer time, all the gray guys here. And if we want to take out only x of 0, we should multiply the sequence x of n by this guy. Because why? Well, when we multiply by this guy, all the coefficients, also all the values of this function is 0. 0 multiplied by x of n will be 0. So the only value that will come out is when the delta n is non-zero. And in this case, of course, we know that delta n is non-zero at time equals to n equals to 0. In fact, its value is 1. So 1 times x of n will give us this function. Everything else is now 0. And of course, we do not need to multiply by delta n. We can multiply by delta n minus naught. And therefore, now we can extract any value of x of n at different n naughts. Okay, so this is the shifting property of the Kronecker delta.